Today we are going to talk about a real problem that organizations run into when they try to scale AI agents with organizational context. Our talk is titled MCP Marketplace Scaling AI Agents with gRPC. We'll show you a possible solution that transforms a complex decentralized problem into a standardized single platform solution built fundamentally on gRPC. Hi, my name is Sumangal.
And I'm Vaishali, and we're part of the platform team driving developer productivity at Intuit. For those of you unfamiliar with Intuit, we are a global fintech platform that provides tools like TurboTax, QuickBooks, and Credit Karma. We serve millions of consumers and small businesses globally, helping them manage their finances and drive prosperity.
So today we will talk about one of the most critical challenges faced in organizations as they scale with AI agents. The question is, how do you give every AI agent access to the exact context that they need securely and at a scale? So here's our agenda for the day. We'll be starting by defining the problem itself, the pain point that drove us into this initiative. You will hear about the gaps in discoverability of MCPs, security risks, and frictions that emerged as we decentralize the context delivery process across various teams in our organization. Next, we will introduce the solution, the MCP Marketplace, an unified platform that transforms how we can distribute organizational context in a secure and a controlled way to various AI agents. This platform consists of two experiences. The first is the producer onboarding, which shows how each service team can streamline MCP development with an automated CI/CD pipelines with minimal friction. Next, the second part of this experience is consumer experience that reveals how consumers can go from discovery to one-click installation with enterprise-grade security and secret management baked in from day one. Finally, we will look into how to measure the success of this platform by tracking adoption, ensuring quality, and building community engagement. By the end, I hope you will see a pattern of how organizations can democratize secure context access and how gRPC makes it possible. To start, we must define the ecosystem. An AI agent is not just a language model sitting in isolation. It is an autonomous entity that perceives its environments, makes decisions, and takes actions to achieve specific goals. But here's the critical challenge. Without proper organizational context, even the most powerful model is fundamentally limited. This is where the MCP or Model Context Protocol becomes essential. MCP is an open standard that serves as a standardized language enabling AI agents to securely request and access contextual data from various organizational entities. Whether it's your code base, internal APIs, databases, or enterprise policies. MCP allows an agent to retrieve exactly what it needs and when it needs it. Think of MCP as a bridge between the raw intelligence and the organizational knowledge. Without it, you have a powerful model, but there is no way to ground it into your business reality. With MCP, you can transform a generic system into a highly context-aware enterprise-grade tool that understands your code base, policies, workflows, and even your business constraints. So let's explore some challenges faced in this journey of exploring AI agents and MCPs at scale.
So, as organizations embrace AI agents, the challenge shifts from how to build an agent to how to scale the agent infrastructure across their developers. The decentralized nature of context delivery quickly exposes a few critical pain points. Let me highlight a couple. First is the poor discoverability. Without a central registry, teams are blind to what already exists. This leads to duplicated effort amongst the developers trying to solve the same context fetching logic independently and in silos. This is fundamentally an enterprise problem. Next is inconsistency and risk. The lack of standards means there is no quality gate. Organizations risk having unverified, buggy, or non-compliant MCP services feeding critical context to the LLMs, leading to unpredictable behaviors and governance issues. Security and auditing is another critical pain point. Without a central system to manage sensitive user credentials or personal access tokens, or to even enforce authentication, there is no systematic way to log which user accessed what contextual data. Lastly, even when an MCP service already exists, the manual setup and the complex runtime configurations required for the local MCPs create a learning curve for the developers, hence slowing down the adoption. So as a solution, we built the MCP marketplace. It is a central registry for discovering and installing context services. Think of it like a NPM for AI capabilities. Just as the developers rely on the package manager for libraries, the marketplace provides them a searchable, curated collection of MCP services to extend their development environment. This platform can tackle the enterprise challenges for both of the sides of the ecosystem. For the MCP producers, we give them standardized tooling and a streamlined CI/CD publishing process. This ensures consistency, simplifies their distribution, and gives them valuable metrics on adoption and quality. We also solve the lifecycle issues like version management and deprecation of MCP services. For the MCP consumers, we get rid of the friction. We provide them a one-click installation. The platform then handles the complexity of authentication, ensuring every service is verified and compliant through the automated quality gates. Now let's look at each of the workflow of the marketplace in more depth.
Now that we have understood what is this MCP marketplace is all about, let's look at how the MCP developers will utilize this platform to publish their MCPs. So as part of the producer onboarding, the developer journey begins with onboarding their MCP project into the marketplace. The marketplace provides an option to automatically create a dedicated repository with the boilerplate code for the MCP service so that the developer can start easily. And then we also going to create a predefined CI/CD pipeline and link it with the repository so that any code changes pushed into the repository would automatically trigger the CI/CD pipeline. This streamlined setup enables development teams to focus more on building the MCP service functionality rather than focusing on the infrastructure configuration. Now if you look closer into the pipeline, the system builds the Docker image and performs the comprehensive security scanning to identify any potential vulnerability before moving forward. So in this case, we are building a Docker image as a MCP. Once the security validation passes, the image moves into the release process. Here, a new version is tagged and stored into the enterprise artifactory. Let's say in this case, a Docker registry. This creates a specific testable release candidate, which is also available in the marketplace for the developer to test. Before going live, developers can perform the final validation by pulling the image with the release tag and running comprehensive test in the pre-production. Once the testing is completed and approved, the image is published to the Docker registry, but this time with the latest tag. This will enable all existing consumers to automatically receive the updated version. So this is a clear, streamlined path to onboard an MCP service to the marketplace. Now, let us look on the other side of the platform, how one can utilize this onboarded MCP with their agentic AI flow.
So now we will transition to the consumer experience and see how the developers can actually leverage these MCP services. And before we understand the consumer experience, let's quickly orient ourselves with some of the components interacting in the developer environment. So on the far left, we have the ID and the agent. The agent is the autonomous entity that requires the context. While often it is part of the IDE, the agent is not specific to the IDE. It can reside and operate outside of the IDE as well. And it retrieves the MCP configuration from an MCP config file. In the center, we have the CLI, which houses the installer module and the middleware. The installer handles the MCP setup, and the middleware is our gRPC interceptor. The keychain is a platform native vault to securely store the user's secrets and tokens. The MCP marketplace, as we just discussed, is the centralized registry. And a key point to note here is that context can either be served by a local MCP, that is a containerized MCP service running locally, or a remote MCP that is deployed in the cloud. And all the critical communication happening between the middleware, the MCPs and the marketplace is handled by gRPC. Now we'll begin the consumer experience. So the journey begins with the developer browsing the marketplace catalog. They search for the verified MCP service that provides the specific context they need for their use case. Once they identify the MCP service, they can get the installation instruction from the marketplace itself. Then, the developer can simply execute that CLI command for the installation. This triggers the installer module, which handles the entire setup. The installer module communicates with the marketplace registry. This is where we account for the two deployment models. If the service is a local containerized MCP, the installer will pull the artifact. If it is a remote MCP deployed in the cloud, the installer retrieves the necessary service URL and connection configuration. Finally, it writes all the required configuration into the MCP config file for the AI agent to use later. Any sensitive user credentials like personal access tokens are not stored in the configuration file. The installer securely stores all of them into the platform native vault, and this prevents the exposure of secrets to the local environment and ensures all of them are kept safely in place. This eliminates the entire complex runtime setup required by the developers. Now we'll look at how the gRPC middleware is our backbone for the consumer experience, enabling seamless and secure operation. When an AI agent starts, in step 1, it fetches the MCP configuration from the config file and connects to the middleware using the stdio. The middleware then orchestrates the entire session. It connects to the marketplace in step 4 to identify the deployment model for each of the installed MCP service. Then it retrieves the securely stored tokens in the keychain. It populates the container environment of the target MCP securely, ensuring that the secrets are never exposed locally. Finally, it orchestrates the connection to the MCP service via gRPC in step 6. It will either spin up the local MCP or it will establish a direct gRPC connection to the remote MCP using the service URL configured during installation. Now, when the agent triggers a context request, the middleware acts as the client interceptor. It immediately intercepts any outgoing gRPC request in step 2 and injects the necessary user authentication headers typically acquired via SSO or OAuth. Now let's address the validation aspect. The target MCP server, whether it's a local MCP or a remote MCP, uses a server-side gRPC interceptor in step 3. This interceptor connects to the marketplace to identify and validate the user's identity based on the injected headers. The MCP service only processes requests that are fully validated. If the authentication or processing fails, the middleware relays the detailed error message back to the agent, allowing the agent to immediately process the feedback and guide the user on the corrective next steps. This robust pattern solves the major security and compliance challenge, ensuring every context access is authenticated. Finally, the middleware acts as the event publisher. It continuously monitors every single gRPC request that flows to and from the MCPs, allowing it to infer the tool usage and latency and capture critical gRPC error codes. This usage data is then asynchronously sent to the marketplace, which allows the data to be sent to the analytics collector. This gives us the necessary audit trail for every context access event, providing real-time quality metrics. So for the MCP consumers, the installation is one command away. No more manual configuration headaches, no more security gaps. You get verified, secure access to the exact context your agents need. Now we'll look at how the marketplace leverages the robust features of gRPC to solve some of the most critical problems. So the middleware is essentially a powerful gRPC interceptor operating on the client side. This allows us to solve the critical platform challenge of centralized authentication. Before any context request leaves the developer environment, the middleware intercepts the gRPC call and injects the user authentication headers. On the server side, the target MCP uses the server-side gRPC interceptor. This interceptor then validates the user's identity and authorization based on the headers injected by the middleware, ensuring only validated, authorized requests are processed. This robust native gRPC pattern is the backbone for security. Next, coming to the token management, the middleware securely retrieves the sensitive token from the keychain and uses them to populate the execution environment of the target MCP. This is how an organization can enforce secure access while ensuring that the tokens are never exposed to the local host machine or the configuration files. But the middleware does more. It also closes the context auditability gaps. It acts as the event collector. Since every request for context flows through it, the middleware can infer and track critical data points. This includes the tool usage frequency, service latency, and crucial gRPC error codes. This usage data is then asynchronously sent to a remote data collector. This systematic logging allows us to definitively answer which agent used by which user accessed what contextual data. Now we will focus a bit more on how we leverage these data points effectively.
Okay, so as we saw, the middleware being a central point, it has a potential to capture the critical usage data for analytics and monitoring. The middleware can serve as a central collection point for all critical usage data, instrumenting key events to deliver actionable insight for various MCP owners. Firstly, it tracks the service installation to identify which MCP services are gaining more traction in the organization. Next, it measures the tool invocation frequency to understand the real world adoption and engagement level from various AI agents. Also, it monitors the real time service latency and gRPC error rates so that it can ensure the consistent performance and reliability across various MCP offered in the marketplace. Finally, it delivers comprehensive analytics on the adoption trend and quality matrices, empowering the MCP owners to make data-driven actions. Looking ahead, we can focus on a couple of key areas such as advanced semantic search, which will enable sophisticated discovery of capabilities that help developers to find the right service and tools faster. We can also see that advanced semantic search can help developers to find the right MCP instantly by matching their intent to the available MCP tools. We are also enlightening the community engagement, enhancing the marketplace with community driven features such as rating, reviews, and usage example to build a trust and facilitate a knowledge sharing platform. What we have shown you today is more than just a technical platform, it's a fundamental shift for an organization in how we operationalize MCPs at scale. Thank you all for your time. We are now open for any question if you have.
I have two questions.
Sure.
First is this marketplace only for MCP servers who are like open source? Like, is there a rate for private server to have it there?
Yeah, mainly we are targeting the private MCP services that are made within our organization.
Okay.
So this solution is in-house for our in-house MCPs.
Okay, right. Thank you. And also, is it only for STDIO?
Currently,
Like only having it on the local, or it's available for like MCP server running outside your system?
right. So right now this is like
Like agent to CLI
Yeah.
is STDIO, right?
correct. So in this demonstration, what we have shown is in a local environment, your agent is connecting to the middleware via STDIO, and here we have highlighted IDE as the agent. Like think of those modern IDEs which helps developers to write code efficiently by help of MCP services. We don't have any other option than STDIO at this point, but if you look at this local environment, similarly in a remote environment, like entire local environment is running inside a pod, then this agent can connect to middleware using another protocol, right? So that there is a possibility for that.
Okay.
Thank you.